Find three numbers in GP whose sum is 21 and the sum of whose squares is 189. So, solution: let the three terms of the GP be AR, AR square, where A is any term and R is the common ratio. By question, it has said sum is 21, means sum of three numbers is 21. That is A plus AR plus AR square is 21. Now let's take A common from all these three terms. After this, let's do squaring both the sides. On squaring both the sides, we are getting this line. This square is for A and this square is again for 1 plus R square. Isn't that? Because we have learned AB whole square is equal to A square B square. The square gets distributed over the terms which are connected by sign of multiplication. So AB whole square is equal to A square B square. This concept will be applied over here to get this line. Now it is supposed as equation 1. After this, the question has said the sum of both squares is 189. So again by question, sum of the squares of these terms is 189. That is A square plus AR whole square plus AR square whole square is 189. Now on opening the bracket over here, we will get this line. Again from here, A square can be taken common. And after this, we will suppose this as equation 2. Now dividing equation 2 by equation 1. So we get this line. Now in this line, this A square will be cancelled. Then we are left with this. After this R square can be written as 2R square minus R square. After all, on simplification, we will get R square. Now we will arrange them. So R power 4 will be written at first, then 2R square, then 1, and then this minus R square will be written out of bracket. Rest of the terms are copied as it is. After this, just concentrate over here. We have learned A square plus 2AB plus B square is A plus B whole square. So this concept will be applied over here, the terms which are in the bracket. Of course, it is in the form of A square plus 2AB plus B square. So we can write this as R square plus 1 whole square. This minus R square as it is. This has changed into this one. Rest of the terms are copied. Now again we have learned A square minus B square is A plus B, A minus B. So here also we have, this is A square minus B square. So applying the formula, we'll get this line in numerator. Again, you can check this portion and this portion can be cancelled. So after cancellation, we are left with this line. Now we will do cross multiplication. After this 7 will multiply all these terms and 3 will multiply all these terms to get this line. Let's bring all the terms in left hand side. We will simplify to get this line. Again, we can take 2 common from all these 3 terms. This 2 can be sent to other side to get 2R square minus 5R plus 2 equal to 0. We will now factorize this expression. So on factorization, finally we will get R minus 2, 2R minus 1 equal to 0, which implies either R is equal to 2 or R is equal to 1 by 2. So when R is equal to 2, Then from equation 1, what is our equation 1? Equation 1 is this one. So let's input the value of r over here. So we kept the value of r over here. We will simplify to get ultimately a as 3. After this, r may be 1 by 2 as well. So let's put the value of r equal to 1 by 2 again in equation 1. So when r is equal to 1 by 2, then from equation 1. So this is our equation 1. In place of r, we are going to keep 1 by 2. To get this line, we will simplify this one to ultimately get a as 12. After this, we got the value of a, we got the value of r. Now let's try to find out the three terms. So when r is equal to 2 and a is equal to 3, required GP is a, ar, ar square. Now let's input the value. Let's simplify and we get 3, 6, 12. So the three terms in GP are 3, 6 and 12. But r may be 1 by 2 as well. So when r is 1 by 2 and a is 12, required GP is a, ar, ar square. So let's get the value. Let's simplify and finally we will get 12, 6 and 3. So at last you will write, therefore the required terms are 3, 6 and 12 or 12, 6 and 3. That's it.